Hi dear students, Santosh here, and today I am going to deliver the lecture number 5 on wastewater engineering, and which deals with the sewage treatment processes, and it is the very important chapter as far as civil engineering and wastewater engineering is concerned. So let us start this subject directly. First of all, we have to discuss the sewage treatment processes in general. In previous chapter, it has been seen that sewage contains various types of impurities and disease creating bacteria. This sewage is disposed of by dilution or on the land, means by using the water or by using the land after its collection and conveyance. If the sewage is directly disposed of, it will be acted upon by the natural forces which will convert it into harmless substances. Which means if we put that sewage into the water, then you know that there is a self purification of stream, and that self purification of stream and oxidization convert that sewage into harmless substances. The natural forces of purification cannot purify any amount of sewage within the specified time. It requires time. That self purification of streams requires time, and if we don't have such a much more time, then we have to go for the sewage treatment processes. If the quantity of sewage is more, then the receiving water will become polluted and the land will become the sewage sick. The land which contains the more amount of sewage is called as a sewage sick land. Under such a circumstances, it becomes essential to do some treatment of the sewage so that it can be accepted by the land or receiving water without any objection. Means we have to treat that water before we have to treat that wastewater, means we have to treat that sewage before it putting on the land or before it conveyed into the water. These treatment processes will directly depend upon the type of impurities present in the sewage as well as standard up to which the treatment is required. So these 2 points are very important for the treatment of sewage. Then we have to discuss the object of treatment. Why this treatment is required, or what is the object of the treatment? The sewage can be disposed of on the land or in water, as discussed earlier. When the sewage is directly disposed of by means of these methods into land or water, the natural purification will immediately start acting over it, and the sewage treatment will be done in due course of time. As discussed earlier, when sewage put on the land or water, in water self purification of stream started, as well as on the land oxidations takes place, but it requires certain time. In case of small towns, when the quantity of sewage is not very high, it can be directly disposed of without any treatment for the small towns or villages. Now if the quantity of sewage is too high or it contains a large amount of waste elements, it will not be possible by the land or the body of water to purify it by means of natural process of purification. In such a cases, the land on which the excessive sewage will be applied will become the sewage sick, and it will create the dirty scenario on the site, as well as it creates the nuisance and objectionable unhygienic smells, and it is the common phenomenon nowadays. If the excessive quantity of sewage is mixed with the natural water course, the water will become septic and it will be totally unfit for the other use. So it is necessary to reduce the quantity of the sewage strength and make it in such way that it can be safe and safely applied to the land or discharged into the natural water courses. The object is obtained by the treatment of the sewage and by reducing its strength. Strength means its strength of waste elements or strength of the bacteria. Thus the main object of treatment unit is to reduce the sewage contents, means solids, from the sewage and remove all the nuisance causing elements and change the character of the sewage in such a way that it can be safely discharged into the natural water courses or applied on the land. Practically, the treatment of sewage is required in big cities and where the volume of sewage is more, as well as the quantity of various types of solids, industrial sewage, etc. is more, and porous land on the large quantity of water body is not available for the proper disposal of the sewage. In case of small towns, there is no such a problem due to small quantity of sewage. So, we learned that if the city is big and amount of sewage is much more and it contains the much more waste elements, in such a cases the sewage treatment is absolutely required. Then we have to discuss the degree of treatment. The degree of treatment will mostly be decided by the regulatory agencies, means municipal corporations, and the extent to which the final product of the treatment will be utilized. The regulatory bodies might have laid down certain standards for the effluents or might specify the conditions under which the effluent could be discharged into the natural stream, sea, or disposed of on the land. What is the effluent? Influent means the initial sewage and effluent means treated sewage. So, you must know what is the influent and effluent in wastewater engineering. These regulatory bodies may be a local body, as discussed earlier. It may be a municipal corporation, or it may be a state water pollution prevention board or control board. The method of the treatment adopted should not only meet the requirement of these regulatory bodies or agencies, but also result in maximum use of end products with economy. So, we can use that end products of the sewage treatment with economy. That is also be object. Then the period of design is also important. You must know the period of design. The treatment plant like sewerage system is normally designed to meet the requirement over years period after its completion. How much period? That is 30 years period. That is important. The time lag between the design and the completion should not normally exceed 2 to 3 years, and in exceptional cases it may be 5 years. So, we can complete that sewage treatment plant within 5 years. Care should be taken that the plant is not considerably underloaded in the initial stages, particularly the sedimentation tanks. So, sedimentation is also here, like that water supply engineering. The treatment plant should be considered as a part of main sewerage project, and the area to be served is to be decided based on the needs of the main project itself. The main project may not be executed at one stage, but may be done in various stages as the development of the area takes place. So, it can be developed into the phases. Phase 1 contains the aeration of that sewage or sedimentation of that sewage. Phase 2 contains the flocculation or filters. In in such a stages we can construct that sewerage project. But in any case, the ultimate period of design of the project should be the 30 years, and to that extent sufficient accommodation should be provided for all the units necessary to cater the needs of the ultimate population. So, forecasting of population is very important in the design, and that forecasting of the population for the 30 years. In some cases, it may be necessary to combine the number of sewerage systems with a common sewage treatment plant. It can be planned to combine treatment of the waste from the nearby industry along with the community waste from the urban areas. So, that treatment plant may contain the treatment of the industrial sewage as well as treatment of the domestic sewage. But in such a cases, it should be carefully investigated whether liquid waste from the industry do not adversely affect either the sewerage system or the treatment processes and could be accepted if necessary with some preliminary treatment so that it can be combined with the sewage from the community or unified and economical treatment. So what we learn, if we want to mix the industrial sewage with the domestic sewage, we have to treat that industrial sewage and it should not affect the overall process of the sewage treatment plant. Then we have to discuss the dumping chutes for the night soil. Detachable dumping chutes are constructed at the selected points in the sewerage system for disposing of the night soil collected manually from the individual houses or through vacuum cars from collection wells in the town, which are only partially sewered. Such a discharges have the effect of increasing the concentration of solids and BOD. BOD we discussed earlier, biological oxygen demand. If necessary, sufficient dilution should be provided to prevent the clogging of sewers. Clogging of sewers means sewer get clogged or it get disturbed, its effective area get reduced due to impurities. In such a cases, the treatment plant will have to provide for the change in the characteristics of the sewage. These dumping chutes should be removed when the sewerage system is expanded to cover the unsewered areas. In such a cases, it should be removed. Then we have to discuss the effluent disposal and utilization. What is effluent? That is treated sewage. The degree of the treatment provided to the sewage is governed by the specific purpose for which the sewage effluent is to be used. The sewage effluent is preferably used for irrigation of the crops, means for sewage farming with precautions. The effluent can also be used for artificial recharging of groundwater or for industries as process or cooling water. So that water can be reused again. Another use of effluent may be at the treatment plant itself for the purposes such as flushing or foam control or chlorinator injector water or lawn sprinkling or for fire protection and general plant operations. That water may be used. In case the as conditions mentioned above are not suitable for using the effluent water for any of the above purposes, it may be disposed of into the natural body of water such as a river, lake, pond or a sea or irrigation canal using necessary precautions. You must underline that, using necessary precautions. That is very important. Then we have to discuss the types of treatment. The sewage treatment unit can be broadly classified as preliminary treatment, secondary treatment and the final treatment. One must know that these three treatments, preliminary, secondary and final treatment. We have to discuss the treatment units or operation and percentage removal of suspended solids, that is very important. Second is bacteria and third is the biological oxygen demand at 5 days at 20 degrees Celsius. That is the standard. 5 days and 20 degrees Celsius is standard for biological oxygen demand, and we discussed that earlier, and it is very important term as far as wastewater engineering is concerned. For the screens, the suspended solid percentage removal is 5 to 20%, bacteria removal is 10 to 20% and BOD removal is 5 to 10%. For plain sedimentation time, as same as that of water supply engineering, the suspended solid removal is 35 to 65%, bacteria removal is 30 to 70% and BOD 25 to 40%. For sedimentation with chemicals, it is 70 to 90%, bacteria removal is 40 to 80% and BOD removal is 50 to 85%. Trickling filters. In water supply engineering, the filters used are rapid sand filters, slow sand filters, but in case of sewage treatment plant, the trickling filters are termed as a low rate trickling filter. The working is similar to that slow sand filter, and trickling filter high rate is working is same that as of rapid sand filter. For trickling filters low rate, the suspended solid removal is 70 to 90%, bacteria removal is very effective 90 to 95% and BOD also removal is 80 to 95%. For high rate, the removal is less 65 to 92%, for bacteria it is 80 to 95% and for BOD removal is 70 to 95%. activated sludge process. We are going to discuss this process in latter part of our lectures, and it also contains ordinary and high rate activated sludge process, which is termed as a ACP, ASP. ASP 85 to 90% is the suspended solid removal. Bacterial removal is 90 to 98%, and BOD removal is 75 to 96%. And for activated sludge process treatment high rate, it is 65 to 96, 80 to 96, and 65 to 96 is the removal percentage of the suspended solid, bacteria as well as BOD. And for intermittent sand filtration, the rate is 85 to 90%. For the suspended solids, 95 to 98% for bacteria removal, and 90 to 95% for the BOD removal. And one must remember all these processes, that such as chlorination is also done for the settled sewage. Chlorination of the treated sewage is also done for biological treatment. One must know all these treatments, starting from the screens and ending at chlorination, same as that of water supply engineering. We are going to discuss the location of the treatment plant, which is the vital part as far as civil engineering is concerned. The treatment plant should be located as near to the point of disposal as possible. So it is very important, it is location, it is near to the point of disposal. If the sewage is disposed of finally into the river or the natural streams, the treatment plant should be located on the river bank. It is also important, it should be located on the river bank treatment plant. Care should be taken while locating the site that it should be on the downstream side of the city and sufficiently away from the water intake works. Why it is on the downstream side of the city? Because it creates the nuisance. So to avoid that nuisance, it should be located on the downstream side of the city. The treatment plant should be on the downstream side of the bathing ghats also. Why? Because the water received on the bathing ghats should be free from such a treated sewage. If finally the sewage is to be applied on the land, the treatment plant should be located near the land or at such a place from where the treated sewage can be easily flow under gravitational forces towards the disposal point. So the location or topography should be such that that sewage should be transported with the help of gravitational forces. That is important. And the plant should not be much away from the town to reduce the length of the sewer line. So length of the sewer line is also the consideration. It should be near to the city, but it should be on the downstream side and it should be away from the bathing ghats. On the other hand, the site should not be so close to the town that it may cause difficulties in the expansion of the town and pollute the general atmosphere by smell and fly nuisance. And it is very important, and one designer must consider this point to decide the location of the treatment plant. Then treatment processes. The treatment processes directly depend on the impurities present in the wastewater, because that impurity will decide which treatment to be given to that sewage. For removing various types of impurities, the following treatment processes are used. When the impurity or waste element is bulky, floating and suspended matter, the racks and screens should be used. Rack and screens means inclined MS steel members or bars, flat bars, which can be used to remove the bulky, floating and suspended matter. For removal of oil and grease, flotation tank or skimming tanks are used. We are going to discuss it in the latter parts of our lectures or upcoming lectures. Heavy and coarse suspended matter, it should be removed by the grit chamber or detritus tank or sedimentation tank. Then non-settleable, which are not going to settle in the sedimentation tank or grit chamber. In such a cases, we need the chemical flocculation. And for colloidal and dissolved organic matters, the biological growth or biological bacteria we are going to use, we termed it as a slims. We are going to use that slims to remove the colloidal and dissolved organic matters. And one must know that we remove the pathogenic bacteria by using the process which is termed as a disinfection. So one must remember the disinfection process. So this is the figure showing the sewage treatment plant. That sewage treatment plant, various elements are designed here. That grid chamber is designed to removal of the grid. Then these are the tanks, sedimentation tanks or skimming tanks are used. In lower chamber, settled solids are, the solids are settled here, we have to remove that solids. Then we have to use the trickling filters also, such as slow sand and rapid sand filters. That trickling filters are used to treat that sewage. We can use the skimming tanks also, and such a tanks are located on this part, and we have to, this part is termed as influent, and this is termed as effluent. This is effluent and this is influent, and these are the various treatment plants. Similarly, here there is a preliminary settling tank, then there is a dosage tank, there is a trickling filters, secondary settling tank, sludge digestion tank, and this is sludge drying beds. So this water or sewage is treated in these various plants, and this treated sewage or effluent is applied on the land. So in general this is the layout of the sewage treatment plant for the large cities. So one must study these diagrams, and one must study the treatment plants in systematic manner or in step by step manner. This is the layout of the treatment plant. In most of the examination it is asked how the treatment is sewage, prepare the layout. So this is the influent, these are the racks, then this is the grid chamber, then we go for the skimming tanks, then we go for the preliminary settling tank. You use the aeration also here, and we can use the final settling tank also to settle all the solids. Then we use that sludge or treated sewage into the sludge digestion tank. Then we send it to the trickling filters, and from that final product is applied onto the land. So this part is called as effluent because it is treated, and this part is called as influent. So this is not treated sewage. Okay, so one must study these layout diagrams. Okay, so you study all these layout diagrams and prepare for the examination. Then we have to discuss about the layout of the treatment plant as discussed in that figure earlier. The following points should be kept into the mind while giving the layout of any sewage treatment plant. All the plants should be located in order of sequence so that the sewage from one process should be directly go into the next process. That is important. From one process, sewage should go to the another process. If possible, all the plants should be located at such a elevation that sewage can flow from one plant to the another plant by the force of gravity only. That is also important. All the treatment units should be arranged in such a way that minimum area is required, and it will be also ensure the economy in the cost. So minimum area requirement is also a point. Sufficient area should be occupied for the further expansion in the beginning. So we are going to design that sewage plant or sewage treatment plant for 30 years. So one must decide the forecasting of population and area requirement. The site of the treatment plant should be very neat and give very good in appearance. Bypass and overflow weirs should be provided to cut off the operation of any unit when it is required. All the channels conduits should be laid in such a way that to obtain the flexibility, convenience and economy in the operation. So economy is also important. Then we are going to discuss finally the points to be considered in the design. The design period should not be more than 30 years, so it should be taken between 15 to 20 years. The design should not be done on the hourly sewage flow basis, but the average domestic flow plus maximum industrial flow on the yearly record basis. So it should be designed for the yearly record basis. Instead of providing one big unit for each treatment, more than two numbers smaller units should be provided. That is very important. Instead of going for the bigger unit, you should provide the 2 units, which will provide the flexibility in operation as well as no stoppage during the maintenance and repair of the plant. So go for the 2 units instead of 1 unit. Go for the 4 units instead of 2 units. Overflow weirs and bypasses should be provided to cut off particular operation if desired. As discussed earlier, self-cleansing velocity should be developed at every place and stage. That is a very important. Self-cleaning velocity is very important part in water supply engineering, and we are already discussed that part. The design of the treatment unit should be economical, easy in maintenance, and should offer the flexibility in the operation. So economy is important, is in maintenance is important, and flexibility in operation is also important. Then we are going to discuss the last part of this lecture, that is laboratory. A well equipped laboratory should be provided at the treatment plant. Why it is required? It is required to check the quality of the sewage before it send it to the land or into the water body. According to variations in the impurities, the treatment processes should be altered. That is also important. One should not go for the fixed treatment, but that treatment should be altered according to type or variation into the waste elements. The efficiency of the plant can be increased by the laboratory test of the sewage during the various processes. That labs tests during various processes is important. Why it is important? To determine the amount of solids, to determine the amount of bacteria, to determine the BOD, to determine the COD. You know the COD also. By testing the sewage after treatment, it can be ascertain whether it should be reached to the required standard at which it is disposed of or not. There are rules and regulations of the local bodies, and to meet that rules and regulation of the local bodies, it is very important to decide that quality of the sewage, it is as per norms or standards or not. So that's why the laboratory is required. Okay. So thanking you all my subscribers. Once again I am going to thanking you. After a long time I delivered a lecture on the civil engineering, but henceforth I am going to deliver that lectures regularly. So thanking you, and for more details and notes you may please contact my administrator, as well as you can write on my email ID. And if my lectures are useful to you, you can explain it to your friends also, and subscribe my channel. Thanking you, thank you very much. Bye.